Hello guys, in today's video we are going to start the new series of nuclear physics. Here we will study first chapter of nuclear physics, that is nuclear structure and properties of nuclei. Here in this video we will cover some basic points related to the nuclear physics. Then we will cover nuclear composition. There are two hypotheses, proton electron hypothesis and proton neutron hypothesis. Then we will discuss limitation of proton electron hypothesis. So let us start with the basic points of nuclear structure. The atomic nucleus was discovered by Rutherford in 1911. The nucleus was consequence of alpha scattering experiment. Actually, Rutherford performed an experiment, that is alpha scattering experiment, and what he observed in that experiment, on the basis of these observation, he made some consequence related to the atomic structure. So, what are the observation of scattering experiment? He observed that most of alpha particles are going straight to the foil, and some alpha particles are going through large angle scattering, and very little number of alpha particles are getting back scattered. So, when he analyzed these observation, then he made some consequence. When he saw that most of the alpha particles are going straight, he concluded that most of atomic space is empty. And when he saw large angle scattering of alpha scattering experiment, then he concluded that there must be positive charge on the nucleus, so that there must be repulsion between alpha particles and nucleus, because alpha particles also has positive charge, so nucleus must have positive charge for the large angle scattering. And third, when he observed that a little number of alpha particles are getting back scattered, so then he decided that the nucleus is very heavy. Bulk of atomic mass lies in the nucleus. So this was main point of that consequence. Bulk of atomic mass lies in the nucleus and all its positive charge resides in the nucleus. Actually, we will discuss it in detail, alpha scattering experiment later on. This was brief introduction of alpha scattering experiment. Definition of nucleus. Thus, Rutherford established that bulk of atomic mass and all its positive charge lies in very small central core of the atom called nucleus. What Rutherford says that bulk of atomic mass and all its positive charge lies in very small central region of atom. That central region of atom is called nucleus. Feature of nucleus: the size of nucleus is of the order of 10 to the power minus 15 meter. 10 to the power minus 15 meter is also called Fermi meter. So you can say that the size of nucleus is of the order of Fermi meter. Hardness: it is very hard structure because of most of mass resided in the nucleus. Position: it is present in the center of atom. The particles which are emitted from the nucleus: alpha particle, beta particle, gamma rays. When radioactive disintegration was performed and particles which are coming from the nucleus were analyzed, it was found that they may contain alpha particle, beta particle, gamma rays. So you can say that alpha particle, beta particle, gamma rays are of nuclear origin. They coming from nucleus. Along with proton, neutron, alpha particle, beta particle, many other subparticles like mesons, positron take part in the constitution of nucleus. Or we can say the nucleus is made up of all these particles: proton, neutron, alpha particle, beta particle, and subparticle like meson, positron, etc. When more particles, one more particle came into recognition when continuous spectra of beta particle was interpreted, called neutrino. When continuous spectra of beta particle was interpreted, one more particle, that is neutrino, were found to be coming along with the beta particles, and it was named as neutrino. And neutrino has negligible mass but plays an important role of carrier of energy. Now, second topic is nuclear composition. There are two hypotheses for nuclear composition: proton-electron hypothesis and proton-neutron hypothesis. So what this hypothesis says about the structure of nucleus: According to this hypothesis, it was considered that nuclear matter consists of proton and electron. It says that protons equal to mass number of the nucleus, and electrons equal to half the mass number of nucleus lies in the nucleus. This idea followed from the fact that electrons are emitted by radioactive nuclei in the beta decay process. When beta decay process was observed, then and beta particles that are electron were found to be coming from the nuclei. It was thought that electrons also lies in the nucleus. There are some limitations of this hypothesis. Because of that limitation, it was rejected later on. So what are these limitations? Energy of electron in the nucleus. For electron to be existed in the nucleus, when energy of electron were found by considering electron in the nucleus, it there there occur large difference between the observed energy and measured, experimentally measured energy. So that large difference was cause of rejection of this hypothesis. Uh, if electron we consider is lies in the nucleus, then the Broglie wavelength should be the Broglie wavelength of electron should be equal to r radius of nucleus. Lambda must be equal to r. Momentum of electron is equal to h by r. Formula is h by lambda, and in place of lambda we put r here. H is nothing but Planck's constant, and its value is 6.6 into 10 raised to power minus 34. When both these value h and r were put here, the momentum was found to be 1.1 into 10 raised to power minus 19 joule second per meter. Value of R is 6 into 10 raised to power minus 15 meter for light nucleus. So energy was come out to be formula of energy is P into C. Value of P is taken from here, and value of C is 3 into 10 raised to power 8, and in joules it is come out 3 into 3.3 into 10 raised to power minus 11. When converted into mega electron volt by dividing it 1.6 into 10 raised to power minus 30, then it comes in mega electron volt and comes in 206 mega electron volt. In case of heavy element, radius is 6 into 10 to the power minus 14 meter, or you can say that 10 into radius of light nucleus. If we put here 6 into 10 to the power minus 14 here in the value in the formula of momentum, then momentum will come out 1.1 into 10 to the power minus 20 meter, and if we take here 1.1 into 10 to the power minus 20 meter, then there will be the result of energy will be 20 mega electron volt. So energy for energy of a emitted electron for heavy nuclei will be 20 mega electron volt. So you can say that energy of emitted electrons from the nucleus must be in the order of 20 mega electron volt to 200 mega electron volt. But energy of beta particles was measured only 2 to 3 mega electron volt. So there is large difference between these values and experimental values. This large difference between the estimated energy and measured energy ruled out the proton electron hypothesis. The second limitation is nuclear spin. When the observed value of nuclear spin also rules out the possibility of presence of electrons in the nucleus. When it was considered that electron is present in the nucleus, then the value of spins are which came are very different from the experimental value. How it we say here we see here, for example, in case of deuteron, the formula of deuteron is this, and mass number is 2, atomic number is 1. So according to this hypothesis, proton equal to its mass number means 2 proton, and electron half the mass number, that is 1. So 2 protons and 1 electron must lie in the nucleus, and electron proton both have half spin. So possible values of spins are plus 3 by 2 plus half minus 3 by 2. How these possible values come? Uh, Depending upon the orientation of pairing, let us see. We denote orientation with upward arrow and downward arrow. Plus half is denoted by upward and minus half by downward arrow. So if these three particles, if all the three particles have up orientation, means plus 1 by 2 plus 1 by 2 plus 1 by 2. So total will come out plus 3 by 2. If two have positive spin, positive half up arrow, and one has negative spin, so plus half and minus half. So it will come out plus half. And if two has downward spin and one has up spin, then minus half will result. And if all the three particles have down spin, then minus 3 by 2 will be resulting spin. So possible values are these, but experimental value of spin of deuteron is 1, which is not lies in these possible values. So the difference of spin value of deuteron and experimental value, it is the difference. This difference occurred due to wrong consideration of presence of electron in the nucleus. Means we have considered wrong that electrons lies in the nucleus. Now, third limitation is magnetic moment. If electron exists in the nucleus, then magnetic moment of nucleus should be of the order of magnetic moment of electrons. But magnetic moment of nucleus was found to be much smaller than magnetic moment of electron. Actually, this difference between magnetic moment of nucleus and magnetic moment of electron was very large, about 2000 times. uh, the magnetic moment of electron is 2000 times the magnetic moment of nucleus. So this observation was also against the proton electron hypothesis. Fifth limitation is dual role of electron. If we consider that some electron are present in the nucleus and are some as peripheral electron. Peripheral electrons means electrons which are moving around the nucleus. So if we consider some electrons are in the nucleus and some are as peripheral electrons, so there must be dual role of electrons, which was difficult to understand. So these were the complication due to which proton electron hypothesis was rejected later on. Thank you.